A few months ago, I asked AI to design a PCB for my project. It looked convincing. It even explained all of its decisions. The only problem, some of those decisions were completely wrong. So I decided to learn a PCB design myself. This is my first real board. And just when I thought I was finished, I sent the design to someone who's been designing PCBs for years. And let's just say, he had the notes. Hi, I'm Kasia. Welcome to my channel. If you are new here, I am building a dog treat dispenser that recognizes a doorbell or knocking and automatically releases a treat for my dog. The goal is training. Instead of barking every time someone rings the bell, I want Simba to think, oh, if I am here, good things happen. Treats. Creating calm and desensitizing to arrival of guests. The prototype already works. And now it's time to turn it into a real product. I have spent years doing system engineering in medtech, writing requirements, thinking about risks, but PCB design? That was a completely new territory. This board has one job. Hear the doorbell, recognize it locally using TinyML, spin a motor, dispense a treat, and do all of that without Wi-Fi or cloud services. So it needs a microcontroller powerful enough for TinyML, a microphone, Bluetooth for configuration and manual feeding, a motor driver, battery management, protection if the motor stalls because a treat gets stuck. For the first version, I chose a dev kit. Is it the best choice? Probably not. But I already knew it worked, and that's something I underestimated when I started this project. I spent far too long looking for the perfect component. Eventually, I realized something. A component you have already tested is often worth more than the theoretically perfect one. Before I even opened KiCad, I started with sketches. Nothing pretty, mostly boxes, arrows, question marks. Turns out there's a research behind it. Drawing activates more parts of the brain than typing. It helps you notice relationships and problems you would otherwise miss. I expected drawing schematics to be difficult. Well, drawing itself wasn't. Choosing components was. There are hundreds of almost identical parts. Every choice affects cost, availability, power consumption, board size, future manufacturing. It quickly becomes overwhelming. AI actually helped me here, not by making the decisions, but as someone to bounce the ideas off. Then came the footprints. Naturally, the boost converter I wanted wasn't in the library. So I ended up downloading symbols, footprints and 3D models from different places and hoping I would import everything correctly. It took me a while. Routing the PCB ended up being my favorite part. It's weirdly calming, like solving a puzzle or coloring in a very expensive coloring book. Power traces need to stay short and wide, ground needs its own plane, lots of vias, lots of moving things around. One thing completely confused me though. Why don't the traces move when I move a component? Apparently, that's how the PCB software works. Another thing I learned is that there isn't one correct layout. And as a person that likes to find the right answer, it's hard for me to get used to. At this point, I thought, well, good enough. But before ordering it, I sent it to a few friends for a review. One of them has been developing KiCad for years. The first thing he questioned was cost. My choices were technically correct, but if I ever wanted to produce it at scale, that would be expensive. He challenged me to build my own boost converter, and I actually did, mostly because I wanted to understand how it worked. In the end though, I still decided to use a dedicated boost converter module. Where he completely changed my mind was the power architecture. My original design had extra switching logic, a MUX, a load switch. His version was much simpler, cleaner, fewer parts, fewer things to fail. He also completely cleaned up my schematic. Mine looked easy. One thing I did add back was a keyed battery connector. If someone assembles it in the future, I don't want them to plug it in backwards. And this is the board that's going to manufacturing. And now comes the scary part. We will find out whether it actually works. The boards are arriving, I will assemble it, test it, and we will find out whether I designed a working product or an expensive coaster. Thanks for watching, and I will see you in the next build.